Okay, good morning. Okay, just a reminder, next week we have a quiz on chapter 11. Maybe on Thursday or Friday, if we have some spare time, we can have another exercise. But for today, I plan to just go through chapter 12, only one section on chapter 12, which is the quadric surface. Okay? So, wait. Okay, the quadric surface is basically if you have conic sections such as parabola, ellipses, hyperbola, okay, and then we can combine those conic sections and make three-dimensional shape from those conic sections. So there are several forms on the quadric surface. We have the ellipsoid, we have the cone, we have the elliptic paraboloid, hyperboloid of one sheet, and so on and so forth. Yeah, we have a hyperbolic paraboloid, hyperboloid of two sheets. So based on all these different combinations, and you will see or you can identify each one of them based on the formula. But I don't want you to just focus on the formula, but I would like to say we are going to focus more on how to trace this shape using the formula or using the given formula. Okay, so I would like to start with the simple surface, which we call the cylinders. So this is what we call the cylinders. Okay. So imagine a three-dimensional space, okay? Three-dimensional space, and you are going to write z equal x squared. Okay? So z equal x squared, if we imagine, like if you see from this side, if you see from here, this is your view. If you see from this part, you will see that this is just a simple x squared, okay? A simple x squared. But if we are looking at three dimensions perspective, we say that this is, we call it isometric view. In isometric view, the parabola that we see, the x squared, is going to be, so in all points along the y-axis, there will be another parabola that we can cut. Okay? So we say that this is, we call it the shape as a parabolic cylinder. And the same way, if we have let's say a circle, for example, the x squared plus y squared equal 1. This is a circle with radius 1. So a circle in x-axis and y-axis, meaning it will be having like this. But if we are going to see from isometric view, we are going to see along the way on z-axis, we have all the circle. So z-axis becomes the center of the circle. So we are going to have something like this, okay? Or if we have y squared plus z squared, we can also have another cylinders. So this is, we call the circular cylinder. Okay, So that is the basic shape, okay, that we can draw from a simple geometric equation from quadratic equation. And then we have what we call the quadric surface. So quadric surface we can write in more general term as ax squared plus by squared plus c z squared and plus the xy plus e yz plus f xc plus gx plus hy plus I z plus j. So it's really long, but basically the quadric surface is basically if we can write some equations taking this as our general idea, and maybe some of them the coefficient may be 0 to make it true. As long as we have the system, then we say that all of these are the quadric surface. So it must be second degree. Okay, it must be second degree equation. So if you see an let's say the third degree, it is not quadric surface. It should be second degree. That's why it's called quadric. It's from the quadratic. And if we rotate or translate the general equation, it can be at least two formulations. It can be just that, or so we only have two forms now. Okay. So this is after by translation and rotation. Okay. Okay, now if we would like to trace the x squared plus y squared over 9 plus z squared over 4 equal 1. Okay, so this is sketch this graph. So the way we do is basically we are going to take some variable as 0. Okay. So trace with z equals 0. Let's say we take z equals 0. So we could see that we have x squared plus y squared over 9 is equal 1. Which we could see that this is actually an ellipse, right? So we can see that this part is an ellipse. And if we are going to, so imagine this is going to be an ellipse in the xy axis. So if we take So if we take the x and y, this will be, this is 3 and this is 1. So maybe it will be about that. Maybe that's the ellipse. Okay. Not really good. So this is the ellipse. If we imagine the ellipse is moving on the z-axis and below the origin, then we could take maybe 1, we get plus or minus with some constant. Okay. So let's plus and minus with some constant. So taking take z as a constant k, then we get that this will be 1 minus k squared over 4. So at most when all this 0, k is 4, so it's going to be k equal 2, right? So k is equal to maybe here, that will be the maximum, or k is negative 2. Okay? So we can see that the ellipse is going to be moved upwards, and they are going to be much smaller. So maybe it's going to be like that, and then make it smaller until it's going to be 0 at k equal 2 or negative 2. Okay. The same way we could see from if we take x equals 0 or y equals 0. Okay. So we could see that we can also taking y squared over 9 plus z squared over 4, which is another ellipse. Okay, which is another ellipse. Or if we would like to take with some constant for x, okay, so x, taking x equal k, this will be minus k squared. And taking the y equal constant, so this will be x squared plus z squared over 4 equal 1 minus k squared over 9. Meaning that this y squared and z squared will be going to be this ellipse. So this will be 3, this will be 2. Okay, I hope you get the conic section correctly. So I hope you know the idea of conic sections, and we are going to use that. In this case, we are using ellipse. Okay. So this means the major axis, which is 3. This means the minor axis, which is 2. So 3, 2, so we are going to start with that. And then we see that the k can be 1 or negative 1. So k will be here at, when it's 0. So it's going to be going that way and that. I see cockroach. Okay, and then x and z is going to be this way. So we can imagine, let me add another one here. So let's say this is 2, so this is 3, this is 1, and then this is another 2 here. So we have another one like that, and then we have another one that is going to be like that. So it's like a ball in the American football. Okay, you see. We call this ellipsoid. We call it ellipsoid. And I think it's quite easy to find because they are all positive, and you see that you cover this, oh, I get the ellipse. Okay. And you cover this, you get another ellipse. You cover this, you get another ellipse. So all ellipses. So all ellipses. Okay. And you call this is the ellipsoid. Okay. So this is the ellipsoid. Okay. Okay. Now next is we would like to sketch z equal 4x squared plus y squared. The same way, if we would like to trace, then we can take some part of the equation as 0. So let's say we take x equals 0, which give you z equal y squared. So just a parabola. Okay. So this is parabola. And if we take the constant as our x, we will get the z, this is 4, or this is y squared plus 4k y. Why it's so sensitive? 4k squared. So if we slice the graph, let's say if we take this is z, x, y. So we have the parabola, let's say this is parabola. Okay, that's parabola. Also the same way we could see I didn't do anything. Why? Okay. Because I cannot use the HDMI. I don't know why. Okay. Okay, and then similarly, we take the y equals 0. And it will give you z equal 4x squared. Another parabola. But perhaps it's more steep. It has high slope, okay? High value of slope. So we can say that the z and x is going to be here. Okay, I think that is good. And then at certain point, if we see the structure of the equation, it's z for x squared plus y squared. Okay. So somehow z will reach some point, some constant, and we are going to see that if we take z as constant k. So let's say writing z as k. So let z equal some constant k. We are going to see that we can write this in terms k over 4, which means that this is an ellipse, right? An ellipse. When k equal 4, this will be an ellipse, okay? So that means the trace above this part will be an ellipse. And you will see that the ellipse will change its axes. Its major axis and minor axis, they always change along the way on the z-axis. So you could see that this is going to be an ellipse over there, okay? And we say that this is the elliptic paraboloid. Okay, or we can see from this part here. So if we trace some part of it, the horizontal part will be an ellipse. The vertical part is the parabola, both of them. So zx is parabola, yz also parabola. Okay. So I don't want you to just memorize, or even I think no need to memorize at all, as long as you can trace the equation easily. So for example, this one 4x squared y squared, we can trace from taking x equals 0 and we will make the parabola. Taking y squared equals 0, this will be also another parabola in y, z, and y-x. And taking the z as a constant, okay, you will see that z as a constant, it will give you an ellipse. Okay? In some way, you have the in x, y will be an ellipse. Okay? Okay, I hope it's clear. Now the next part is I think the one of the most complicated one. So sketch z equal y squared minus x squared. Again, we can start from taking some x equals 0 or y equals 0. So let x equal 0. This gives you z equal y squared. Okay. Taking y equals 0 is giving you z equal minus x squared. So you will see the y squared will be like this, okay? And you will see the z minus x squared will be like this. It's having the parabola facing upwards and facing downwards. So you will see that from these two conditions, let me copy this. Oh. Okay. So z and y squared, it will be, you write this is z, x, y, x, z, y. Okay. Now z and y squared, this will be like that. And if we take the x equal k, so if x equal k, z will be y squared minus k squared, sorry, k squared. And then when y equal k, the z will be minus x squared minus, or in this case, I think k squared minus x squared. So k can be, let's say, can be positive, can be negative. So you can see that we may have a graph that looks like, maybe if we have 1 here, let's say this is 1, this is negative 1, we're going to see that it's going to be downwards a little bit, maybe over there. Be here, so this will be, let me use different color. So it's supposed to be like that. So it's going to be down on 1 and also down on negative 1 here. So you see that? Okay. And for the z equal negative x squared, this will be like that. Okay. And then we can check maybe k equal 1, k equal negative 1. It will be 1 minus x squared. 1 minus x squared for y equal 1 will be here. It will be, it's going up here. Let me get in different color. So it's going to be here. And it's going to be that way. So you'll see that at every point, for example, this x-axis, we add maybe 2. It will be lower. Okay. And also you cannot ignore the points in between. So you can imagine that this is going to be the downside of the curve. It will be going that, and if we go over the negative axis, it will also going that way. Okay. This one is like that. Okay. So it's going. So it's from the middle part. You are going to the negative part of y, and you're going to the positive of y. Okay. Like a tunnel. You can imagine like a tunnel. Okay. Tunnel. So you have a car, and it's like a tunnel. And then the second part of this sketch is taking z equal to constant k, which gives you y squared minus x squared equal some constant k. Which this is the hyperbolas. Okay, so this is hyperbola. So both of the first one, they are parabolas, both of these. But when z equal constant k, it will be the hyperbola. And what's happening if we have the hyperbola? Then we could imagine that the hyperbola will have from y and x. Imagine that this k can be 1 or let's say negative 1. If k is 1, we have a hyperbola. So imagine that the hyperbola, let's say k is 1. Okay, so hyperbola will be y squared minus x squared equal 1. And we can also have k negative 1, which give you y squared minus x squared equal negative 1, or x squared minus y squared equal 1. Okay. These two hyperbola, based on the y and x, if you remember the hyperbola, positive, negative, you will have one hyperbola will be, so imagine that this is the x and y axis. Okay, so let me just draw 2 dimension first. Okay, and hyperbola has the asymptote, right? The line diagonal asymptote like that, right? And we are going to have something like that, and something like that. Okay, if we see from the top, okay. So this will be xy. So let's say this is y, this is x. Okay. So imagine that this will be, if we put into the 3-dimensional perspective, so we have in x and y, we have something like that, and we have another one, okay? Another one from here. Okay? Now if we want to write all the traces within the graph, so this is, if we see from 2 dimensions, okay? And then this is what we have before, the traces. So this is for the z equal y squared, this is for z equal negative x squared, okay? And this is for the hyperbola. So the hyperbola, as I mentioned, we can have negative 1 or 1 for a case. If we have 1, then it's on the top, like that. Remember that on the positive 1, we have a y squared minus, so which means that we are going to have y as our axis, okay? And the other part is x squared minus y squared. So x squared is positive, which means it's going to be the major axis, okay, if you remember the hyperbola. So on this one, at the z equal negative 1, it will be like that. But of course, we are going to trace in every number in between. Okay. So what we have is actually something like this. So maybe start from the left part. They are the same thing, but let me start from the left one here. You see that this is on the downside, the hyperbola. It's connecting to our parabola, that is z minus x squared. Okay, and see that this is when we move to along y-axis, we see that it's going to be higher. It's going to be higher. So it's going to be higher like that, right? And higher, okay? And if you see the z equal y squared, this is the parabola. And you will see that this is actually going down like that, okay? And going down up until we get to the positive x. Okay. And then this is going to be the hyperbola. Okay. This is for negative 1, this is for z equal 1. Okay. And this is something that I think easy to understand, that this is what we call the, like the, when you ride a horse, you need to, this horse needs to wear a saddle so we can hop on to the horses, right? Have you ride a horse? No. Really? When you're still kids, no? Really? Why? It's so fun.
Professor, so when we check like x equal to 0, y equal to 0 is, we want to check the relationship between like
yeah, we want to check the relationship, like what will be the line. Okay. what will be the curve in every possible value. You can check 0 or maybe some constant. Okay, so a saddle. So when I was a kid, I used to ride a horse near my hometown. And this point here, this is what we call the saddle point. This is the saddle point. This will be, I think, quite important in chapter 14, which we will discover later. So I think for our course, after we finish this chapter 12, the short section of chapter 12, we are going to jump to chapter 14, okay? Because chapter 13, I don't think necessary, because it's actually derivative integration, same thing we did in calculus 1, but we are going to use it in a factor. I think the only applicable relations that is relatable for you for chapter 13 is the curvature, and I don't think necessarily going to be important in the other section. So I think I will skip that for now. If I have time, I will just give you some additional information. Okay? So there will be no chapter 13 in the exam. Okay? So we skip chapter 13. Okay. Okay. So this will be we call this a hyperbolic paraboloid. Okay. We call this hyperbolic paraboloid. Okay. Okay, one more sections, I think one or two, and then we can wrap up the chapter 12. Okay. The last one is, let me just give you the formula. So this is the surface of x squared over 4 plus y squared minus z squared over 4. Okay. So you will see that we have, if we close one of them, if we close this, we have an ellipse. If we close the y, we have hyperbola. If we close x, we have another hyperbola. Right? So where is the hyperbola? Will be here. Okay, that hyperbola. And the ellipse, as we see, the ellipse is on xy, so I'm on this one. Okay. And of course, okay, we can combine all the formula in quadric surface and exchange all the, like, you can rotate this like maybe like that, which means the ellipse can be in this xz or yz, okay, depends on. Okay. As long as you know the combinations, and to know that, maybe one way to check is like the fastest way. You can cover this and then you can imagine, oh, what is this? This is ellipse, maybe parabola, maybe hyperbola. Okay, that's, I think, only three conic sections that will be possible. Either parabola, hyperbola, or ellipse or circle. The circle is not really often mentioned. It's I think frequently mentioned about ellipse. So of course this is, you can check x squared over 4 minus z squared over 4 equal 1. This is when y equals 0. And y squared minus z squared over 4 equal 1. This is when x equals 0. And then you have x squared over 4 plus y squared equal 1. This is when z is equal to 0. Or if you want to make more clear, we can make this as something like that. You can take z as a constant. Okay. yeah, I think that's all. So as a conclusion, this one will be the conclusion. Okay, one left is this. This is actually similar to this one. This one we call it hyperbolic of one sheet. This is two sheets. The difference is we have plus plus minus. This is minus minus plus. Maybe you can set some formula and then memorize just a few of them. And then the other one you can just relate with that formula. For example, you could see that this one is having all squared, but you have combination 2 positive, 1 negative, or 2 negative, 1 positive. And then I think ellipsoid easy to follow. All the squared and it's plus plus plus. And the rest is having at least one of the variable will be just linear. Okay, I think that's it for today. I would like to give you some feedback questions, okay? Is that okay? Just to make sure, checking your okay, go to the joinmyquiz.com and enter the code. Please use your student ID. Okay, don't use your name. Easy for me to sort and then to list. I think only 3 questions and then we can finish. About chapter 11. About chapter 11. Okay. Are you ready? No? Okay, well, I think anyone have problems? Get thinking. Okay, I think we can start. Who hasn't got in? Okay, I think we can start. Okay, only 3. It's fast. The last question. I think a little bit calculation. Find the integral of the Okay. Okay, only one person correct. Okay, that is the